Hi, my name is Ed Goad. I'm an instructor at Green River College. In this video, we're going to talk over how to configure servers inside a packet tracer and what some of the capabilities are once we've configured them. For this video, this is the network we're working off of. We have two different servers that you can see there at the bottom, server A and server B. Server A will have an IP address of 192.168.1.10 with a Class C subnet, and the gateway will be 192.168.1.1. Server B will have an IP address of 10.1.0.11 with a /24 network, and then a a gateway of 10.1.0.1. Let's go ahead and get those configured, and then we'll see how this can benefit us and some of the other features that work inside of these servers. So here I have my packet tracer environment. I've already configured the IP addresses on my router, and when I hover over the router here, it should shortly show me the IPs that are assigned to the 2 gigabit Ethernet address. Let's go ahead and configure server A. I'm just going to click on it, and it opens up this window right here. We have a couple of tabs up here. Here's the physical view. We can see there's a network cable, there's some hard drives, there's even a power button that I can use to turn it on and off. There is a config section, which will help me configure the IP address. It's not exactly where I want to configure it. There is a services section, which we'll come back to shortly. A desktop section where most of our configuration and tools will be. Even a programming section where we can upload simplified Python scripts in order to automate some tasks. And then lastly, some attributes that could be helpful if we're trying to track power utilization and cost. I'm going to come back to the desktop tab, and here we have lots of different tools. We can see we have IP configuration, terminal, command prompt, web browser, and so on as we scroll through. Because the first step is to configure the IP addresses, I'm going to choose IP configuration. Now this is the left server or server A, so I want to configure it with an IP address of 192.168.1.10. And when I click into subnet mask, it tries to automatically assume this is a Class C because that's based off of 192.168. Networks are Class C networks. I do also need to specify the default gateway. And if I had DNS, I could configure that here as well. Now that that's done, I'm going to click the X there, takes me back to the rest of the tools, and I'm going to click the upper X to close all of server A. Let's go ahead and repeat the same step on server B. Desktop configuration, and the IP is 110.1.0.11. Here, the subnet mask is wrong. Since the 10 dot network is a Class A network, it assumes I want a Class A subnet mask. I'm going to change that and then give the default gateway 10.1.0.1. Quick note, I could also choose DHCP if I had a DHCP server in my environment, as well as configuring IPv6 addresses. Now that our two servers are configured, now we can start using some of these other tools. I'm going to start with the command prompt. If you're familiar with the Windows command prompt, this is a simulation of that. The simplest thing that we can do is use ping. And since both of our servers now have IP addresses from server B, I should be able to ping server A. So ping and server A's address, 192.168.1.10. The first one may time out, and this has to do with ARP requests in the network. This is completely normal in a physical environment as well as in Packet Tracer. So we can see the first one timed out. However, after that, they continued working. If we look back at the network diagram, that means the IP packet or the ping packet went from server A through the right switch, up to the router, to the left switch, down to server A, and then back. Now that we've gone through that, and with our basic configuration, let's look at some of the other options that are available to us. That's going to be under the Services tabs. The servers in Packet Tracer have lots of different services and capabilities that are built into them. By default, it starts us here on the HTTP page. And we can see HTTP is currently on. HTTPS is currently on. And there are some sample pages that exist for us. Because that is on by default, that means that we can start using a web browser to immediately test to see if that web services are working. I'm going to go to the desktop here. Already through ping, we confirmed we can communicate to server A from server B. One of the other tools we have here from the desktop is the web browser. And so if I open up the web browser and I type in the IP address of server A and I press go, we'll see that it connects up to server A over HTTP. We can confirm that up here. It says HTTP. We can even change this to HTTPS since both are enabled by default. Click go. And in this case, we don't see any change because there isn't any change between the two services. Additional services, DHCP. We can configure DHCP on one server and then have it provide addresses for the rest of the network. DHCP version 6. TFTP is on by default. So if we want to use TFTP to load configurations or upgrade firmware to our Cisco devices, we can simulate that here. We can configure DNS so we can have name resolution. We can use syslog to send logging messages to a centralized source. We use authentication, network time, email, FTP, some IoT services, as well as virtual machine management and even Radius EAP. Those are all the services, and when we look at desktop, we will see that there's oftentimes a lot of accompanying tools for it. Such as the AAA accounting, emailing, text editors, NetFlow Creator, Telnet, and SSH clients. We can use these to then work with those various services that we saw. The ultimate goal is to be able to reproduce and simulate our production environments in a lab environment so that we can then possibly make changes and confirm that they work properly.